Hi guys, recently I was wondering if I could make two magnets hover above each other. Those magnets are just permanent magnets taken from a microwave oven of a magnetron, which have holes in the center. And one magnet I have placed on the tripod, and the other magnet is hanging on an aluminium pipe, currently on top here. And the pipe is hanging on a thread that is hooked up there to a hook. So there's quite a distance, about a meter or so. And so if I place this magnet right there and let this magnet come down, it should hover above this one. But of course, as we all know, magnets are quite unstable, or the fields are quite unstable when it comes to moving them. So if I put the other magnet down, it will probably go to the side, to some side, and then swing around. But then I was wondering that this movement would be chaotic, and I really couldn't think of a way how this would stop. But then there we have a principle, that's the principle of conservation of energy. And since there is always some friction involved in such movements, for example the thread or the friction by the air, this movement should come to an end. Otherwise we would have a perpetuum mobile. And everyone knows, at least every physicist will know, that this is impossible. So and now I will lower the upper magnet and see what happens. Alright, now I will let the thing loose. Okay, as expected, it is moving to the side, and more or less chaotically. Or I could give it some kick to this side, so it's a bit more moving around. And it's really strange. It's definitely not a normal oscillation. Well, I've done this experiment before, and this will go on for about an hour. And so I could leave it running like this, but I will of course make a pause and then later show you what has happened in the end. Spoiler, the magnet, upper magnet, will come to a stop, as strange as it may sound, and it will also look strange, as you will see. But again, this will take quite a while. I have to say, this oscillation takes such a long time because of the length of this thread and the small surface area where friction occurs. That's very small, and so there's almost there's very little energy loss. So this oscillation takes quite a while, and we have got not a lot of wind here or a lot of air resistance, so this will really take quite long. Okay, I will now pause. Now take a look at this. This looks really weird. Movement has almost come to an end. You could say it has ended. But it will completely stop soon. And I'll just wait another few minutes. Strange, really strange, isn't it? As if somebody was holding it here with an invisible hand, aside from the other magnet. This looks really weird. Now the movement has completely stopped. There's absolutely no movement anymore. And this is, by the way, a very nice example of the principle of conservation of energy, where this principle predicts that this movement will end, where you might have thought that the chaotic movement will certainly end up in very slight movements that will never end, because the upper magnet would not be able to decide where to go. But that's not the case, obviously. So there we can see that principles in physics make a lot of sense and also make a lot of predictions. Correct predictions, that is. Now let's take a closer look. The two magnets still repelling each other quite a bit on the side here. Now, as I said, I will now try something, another experiment, moving my hand through the whole thing. Let's see what happens. There's a fly going around. Not as expected. There's no movement. That is quite a bit strange. Let's try something different. I'll move a piece of stainless steel now in between, and I suppose this will weaken the magnetic field, and therefore the upper magnet should go further to the center above the other magnet. Now let's put this sheet in between. Nothing changes. This is weird. Why doesn't it change? Why doesn't it move? The force field should be weakened. And therefore the upper magnet should move further to the center. It doesn't do that. Got to find an explanation for that. Let's try something different. We've got an aluminium foil, and well, it's just also a non-magnetic material. I just need to take care that it doesn't touch the magnets. Or maybe the effect is so small that you cannot recognize it. But I don't think there is any effect. Oh, no, I touched it. That was stupid. But there is no effect. Perhaps if I take some piece of iron, which can be magnetized, maybe that will change things. So I will first try something different. So let's use a piece of glass and see what happens. Not much, or nothing. I think the word is permeability. So permeability of those materials seems to be very low, so that there's almost no effect, no visible effect. I'll now take a piece of plexiglass and see if something happens there. Now here goes more than 1 centimeter thick plexiglass. It rotates, but it's... oh, touch it again. It doesn't matter, it doesn't move very much. Now there seems to be no visible effect. Okay, since nothing had a visible effect so far, I will take steel, which can be magnetized, and I strongly suppose that this will have some visible effect, because the magnets will attract it. Yeah, there we go. Oh, upsala. No, it's sticking to it. I didn't want to do that. let's move it through. Yeah, got a lot of effect, lots of effect. Yeah. Let's stop it a little bit here. Yeah. You might wonder why, if I move it like this, right above the center of the other magnet, and then let it loose, why it does move to the side with quite some impulse. Now, you might think that this contradicts the conservation of energy, but it doesn't, because if I hold it like this, then I have to apply quite a force, or quite some force to hold it in position, and I had to bring it into this position, and therefore I had to do some work in this physical sense, and this means I had to put some kinetic energy to the magnet and move it here, hold it here, and if I let it loose, then this energy that I applied before that will be converted back into kinetic energy. So there's no magic involved here. It's all within the principle of conservation of energy. But still, it looks very, very weird to see what I mean. This is weird, weird. Push this a little bit further up to increase the force. Okay, now fix it with a screw. Now if I want to put it there, and now let it loose, it will move even further to the side. You can even see the tripod moving around. Now it's falling down. That's the kind of forces involved here. Alright, very nice. I hope you got some insights if you didn't already know this effect or these effects. And I hope you liked the video. And if you did, please give me a thumbs up and maybe subscribe. See you next time. Goodbye.